Let's talk about the verification process, the interaction between a verifier and a user. A verification is basically an interaction where there is a question asked by the verifier to the user and an answer created by the user and sent to the verifier. Focusing on the question first, what can the verifier ask to the user? The verifier can present a query looking for two types of answers. The verifier can ask for data or for proofs. Asking for data, for example, is when a verifier asks for what is your country of residence. Asking for a proof is for a verifier to ask you for a proof that your country of residence, for example, is not North Korea. In the first case, you are sharing a piece of your credentials stored in your wallet. For the second part, you are creating a zero-knowledge proof based on the credentials that you have in your wallet. How can these questions be created by the verifier? In the case of data, it's quite simple. The verifier references a schema and an attribute. Schemas are the skeletons, the templates that we use to define credentials. So a driver license may have one schema, a national identity card may have a different schema, and a university degree may have a different schema, each schema telling which attributes are stored inside that credential. So the verifier will reference a schema, usually known publicly both by the user and the verifier, and reference one of the attributes or many of the attributes that he wants to access from the credential. That is in the case of data. In the case of proofs, right? The question is a query, is prove me that this attribute or set of attributes are either bigger than this or smaller than this, are included in this list or not included in this list, are equal to this value, right? So to create these questions, Polygon ID introduces the zero-knowledge query language or ZK query language that allows the verifier to create this type of queries. This attribute has to be greater than, lower than, equal, included in certain list of values, or not included. Okay, so using this language, the verifier can create complex queries that have a yes or no answer. In the end, the proof is always a binary yes or no to this set of conditions. Who can ask these questions to the users in terms of applications? They can be, the verifier can be an application, a Web2 application, or it can be a smart contract. We provide different tool sets for each one of these cases. In the case of the application, we provide an SDK. In the case of the smart contract, we provide another smart contract that can be referenced, right? Where we will be sending the query and getting a yes or no answer to that proof sent by the user. Now, once we have the answer from the user, we need to trust in that answer. We need to provide the elements to the verifier so he can trust that the answer is right and can be trusted, and all the actors that participated in the issuance of that credential and the presentation of that credential to the verifier can be trusted. For that, the user is sharing not only the proofs, but also another set of public information. There are a number of things that we need to, or the verifier has to check to trust the answer. First of all, the verifier needs to know that the credentials are still valid. That means they have been not revoked by the issuer. Second, the verifier needs to know that the user that is signing the transaction is using a set of public-private keys that are still under the control of that identity, right? So the keys for the user are valid. And last, the credentials that were signed by the issuer right? We need to make sure that the issuer is still in control of these private keys that were used to sign that credentials. That provides validity to the credential if we trust the user, right? So the keys for the issuer are still valid. All these proofs, all these controls are sent with the answer. So the client, the wallet that the user uses to present these credentials, will send all this public information along with the proof. Some of this information will be sent directly in this dialog. Some of this information needs to be checked on chain, like revocations or the identity state of the issuer to check that the keys are still valid. The verifier has two options to do this. The verifier can go directly to the blockchain and check for all these attributes, these identity states, and check the validity of the keys. Or it can use the resolver, right? As the identifier has a resolver, this resolver can fetch the information from the blockchain to make the process easier for the verifier. And that's how the verifier can create different types of questions, elaborate complex queries, present these queries through either applications or smart contracts, and then trust the answers that they get from the user.